Okay, this is going to be the starter. I want you to work out whether these triangles are right angle or not. So you're going to use Pythagoras for that. So pause the video, try all 3 questions. If you're not sure, I'm going to give you a hint in 10 seconds. Okay, so for those of you that are not sure how to do this, you are going to use Pythagoras' theorem. We're going to find the hypotenuse. We know that this is going to be A, this is going to be B, and then we're going to write out the theorem. So A squared plus B squared equals H squared. And I can see that 24 squared plus 10 squared equals, well, it should equal 26 squared. So question mark, does it actually equal that? So 24 squared, I'm going to do that on my calculator. I get 576 plus 10 squared is 100. I don't know why I use my calculator for that. So that obviously equals 676. And now 26 squared, it does actually equal 676. So therefore we can say, using Pythagoras backwards, yes, this is a right angle triangle because Pythagoras applies to it. Okay, so then question B. So you should have done this by now. If not, pause the video. So we can see this is the hypotenuse. And then this is A and B. Or you might have A and B the other way around. So I can see from there that A squared plus B squared equals H squared. So 9 squared plus 12 squared equals, well, let's work this out first. So 9 squared plus 12 squared equals 225. Now I need to work out H squared. So 18 squared equals 324. Now 225 is obviously not equal to 324. So Pythagoras doesn't apply to this triangle. In other words, this is not a hypotenuse. Even though it's the longer side, the reason it's not a hypotenuse is this is not a right angle, as we've just discovered, because Pythagoras is not true for this. Okay, last question. If you haven't done it, pause the video. Okay, now I'm going to go through the last question. In this case, you may have noticed that it's quite tricky to spot where the hypotenuse is. You have to use your knowledge of triangles here though. The hypotenuse is always going to be the longest length. So in this case, if this is a right angle triangle, then this has to be the hypotenuse. This has to be A and then this has to be B. So let's work this out. A squared plus B squared equals H squared. So I'm going to make 13 squared A, and then B squared I'm going to make 84 squared. Now 13 squared plus 84 squared gives me 7225, and then 85 squared gives me 7225 as well. So therefore, you can do these 3 dots. That means therefore, this is a right angle triangle. Okay, I'm going to show you part 2 of the starter, so I want you to do this by yourself. So here are the 2 questions for you to try. Question D and E, pause the video, and then I will go through it in a minute. Okay, so going through these questions, a triangle has sides 23.8, 31.2, 39.6. Is it a right angle triangle? I'm going to move question E just a bit lower down. So we're still just going to use Pythagoras. Now you can draw a triangle out here, but you can just kind of use a bit of common sense as well. This has to be the hypotenuse if it's a right angle. So then let's write this out. A squared plus B squared equals H squared. Now 23.8 squared plus 31.2 squared. Let's find out what that gives us. 23.8 squared plus 31.2 squared. It gives us 1539.88. And now we can work out h squared from this. So 39.6 squared. Now, if it turns out to be the same, then this is a right angle triangle. So 39.6, make sure you can do this on your calculator. You do get 1568.16. Now, obviously, they're not equal. These two things are not equal to each other. Therefore, it's not a right angle triangle. It is a triangle, but not a right angle triangle. Now, in a question like this, where it says show how you decide, you have to write in a test. You have to say, Pythagoras does not apply. So I'm just going to type it rather than write it here. So you can say Pythagoras does not apply here, therefore it is not a right angle triangle. So I expect to see this in your notes as well. And then the last triangle on the bottom here. What do you notice about this triangle? Yes, excellent, well done. It's basically not a right angle triangle. You can see it is an equilateral triangle. So you can see these two lengths are 3, therefore that is going to be 45. No, actually, this is a right angle triangle. This is going to be a right angle, isn't it? If my pen works. It happens to be a right angle triangle that's also an isosceles triangle. So you can see those two lengths are the same. So your 90 degree is there, which means your hypotenuse is there. That's your h. Okay, so we have a squared plus b squared equals h squared. So 3 squared plus 3 squared equals, well, we can do this in our head, we know it's going to be 18. Now if h squared is 18, well, 4.24 squared equals, let's find out what that gives us. We get 17.9776. It is very, very, very close, but not exact. So it's really close to being a right angle triangle, but it's not working out here. So in this case, you can say that this is not a right angle triangle. It's just off by the tiniest amount. Okay. What we're going to look at today is problem solving with Pythagoras. So you're going to notice that we've started off by doing basic Pythagoras questions, finding the hypotenuse. We had a lesson on finding the shorter side. And then we had a few examples just now of where you are doing Pythagoras in reverse, where you're being given the triangle and you're figuring out if it has a right angle or not. What we're going to look at now is questions where you don't have a diagram, you have to construct it. Okay, so here's a question, pause the video, sketch a triangle out. It should take you about 2 or 3, well, maybe 10-15 seconds just to sketch it out. It doesn't have to be particularly big, and then I'm going to do it and you can compare. Okay, so this is what I see when I have this triangle. So we have a ladder. The bottom of the ladder is 2 meters from the foot of a wall, and the top leans against the wall. So this is your wall here. These are just the bricks, and then we can see ladder is 5 meters long and it's 2 meters from the wall. So this distance here is just a sketch. That's 2 meters, and then that distance there is 5 meters. That's the ladder. And you can see, well, this has to be a right angle, assuming the wall is a normal wall. And it says, how high is the top of the ladder above the ground? Well, this is your ground here. Essentially what we're finding is this distance. And we can see we've constructed a right angle triangle from this, so it's going to be fairly straightforward. We know that this is the hypotenuse, and then this is your A, and this, I'm going to make this my B. So we can say A squared plus B squared equals H squared. Finish this off, have a go, and then play the video. Okay, so this is what you should have got. 2 squared plus B squared equals 5 squared. And then we can take away 2 squared from both sides. So I can say B squared equals 5 squared minus 2 squared. We don't need a calculator for this one. It's just 25 take away 4 is 21. And then this is the bit where students always forget to square root it. So hopefully you would have done that. So you square root this side, you square root that side. So you get B is equal to the square root of 21. This is your exact answer. And then you can round it using your calculator to 4.58. Or you can say B equals 4.58 meters. And then in brackets you can put 2 decimal places, and in this case it was root 21 meters, that's the exact answer. Okay, so I'm going to do one more example here. Before I do it, I just need to make sure you guys know north, east, south and west. Just draw a little sketch in your book and label it. Okay, so you should have got north, east, south and west. You're going to be expected to know that. So sometimes you can have stuff like never eat shredded wheat, or some ways to memorize that if you're not sure. So here it says, let's do this question. Pause the video, try it first, and then I'll do it. Okay, so I'm going to do the question. So a ship sails 300 kilometers west. So it starts at some point and it goes west 300 kilometers. I'll put the units just on the side, just all kilometers. And then 100 kilometers due south. So that means it's going to go down from this viewpoint. It's going to be 100. And then it says, at the end of the journey, how far is the ship from the starting position? Well, we want to know this distance here. And look, we have a right angle triangle. Okay, so here you're just going to do A squared plus B squared equals H squared. And then we can label everything here. So the hypotenuse is actually what we're finding. And then we can call this A and we'll call this B. I'm just going to keep that neat though. So let's just call this H, A, B. So 100 squared plus 300 squared equals H squared. So that will be 100 squared plus 300 squared on the calculator is going to be 100,000 equals H squared, and then we're going to square root the answer. So square root, and then we get H is equal to 316.23 kilometers. I'll put the H here, and that is to 2 decimal places. Hopefully you got that as your answer. So if you did, you're ready to move on to the exercise here. So pause the video, try all 5 questions. I want you to show all of the working out. You're going to need to upload it today. And then I will show you the answers for this in the video in a couple of minutes. So you can pause it here. Okay, so you should have finished all 5 questions. If you haven't, just pause, keep pausing it. I'm going to show you the answers now, just to mark your work. So here are the answers. If you're not sure about any of these, just leave a comment on the Google Classroom and I can go through it. But I expect to see you're working out how you got these answers. Okay, next part. Now, we're going to do just two short examples of more Pythagoras questions, which are not necessarily obviously Pythagoras questions. So it says, which of these rectangles below has a longer diagonal? So when we talk about a diagonal, we're talking about this length here or that length there. And it's the same for these two triangles, this rectangle on the right. So the question is, which has a longer diagonal? Explain your answer. Well, you know that they're rectangles, so these all have to be right angles. Yeah? And then you just use Pythagoras. So pause the video, have a go, and then I'll go through the answers. Okay, if you haven't finished, pause it again, finish it off. I'm going to go through the answers. So the first thing I want to do is find my right angle triangle and then label it and go through it. So here I can see that also has to be 3. So this is going to be a hypotenuse. So a squared plus b squared equals h squared. That's going to be 5 squared plus 3 squared equals h squared. And that's going to be 25 plus 9. And that 25 plus 9, so that is going to be 34 equals h squared. I'm going to square root both sides. The square root of 34 is 5.83 to 2 decimal places. In fact, since we're comparing, I'm going to be more accurate just in case. So it's 5.83095 centimeters. And that's still rounded. And there's still 3 more decimals on my calculator. In fact, let's write them all out. 1895. 951895. Okay, this might be too accurate, but that's fine for now. And then the second one is going to be 3.5, and that's my hypotenuse here, or in this case we'll call it the diagonal. It's the same thing, so a squared plus b squared equals h squared, and then I can say 4.5 squared plus 3.5 squared equals h squared. And on my calculator I can do that. 3.5 squared plus 4.5 squared, and then square root of the answer. So I get 65 over 2 equals h squared, and h is equal to the square root of 65 over 2, which is 5.70087 ... So in this case I actually didn't need to be that accurate. You can obviously see that the blue triangle is the blue diagonal is a lot, well, slightly bigger, 5.8 compared to 5.7. Okay, when it comes to explaining your answer, you can say that you're using Pythagoras. You can say that there's a right angle triangle being formed and we're looking for the longest side. Okay, now I mentioned these in the previous lesson. Pythagorean triples. Pythagorean triples are special cases of Pythagoras. So if you go back to the previous example, you'll notice that here our lengths are 5, 3, and then 5.8. So we've got some decimal here. And in this case, we've got decimal, a decimal, and another decimal. So there can be some various combinations of whole numbers and decimals. Pythagorean triples are where you have all integers, all whole numbers. So this is the most obvious, most common example is 3 squared plus 4 squared is 5 squared, and it is a right angle triangle. Now, what you're going to do is use Pythagoras' theorem to determine if the following sets of numbers are Pythagorean triples. So here are your numbers. and you are going to decide if these guys are Pythagorean triples. Try this in your book, show your working out, and then mark your own work. You're going to know if you're correct or not, so it's self-marking. Okay, pause the video if you still need to see the questions. I'm now going to move on to the next slide. So this is the working out. The working out for this I'd expect to see in your book. And that is going to be it for today. I'll see you in the next lesson. Don't forget to smash that like button. In this case, you literally do have to smash the like button because it actually is a like button. Hit subscribe, check out my Patreon. I'll see you guys in the next lesson. Bye-sies.